So we want to find a line integral over the vector field x squared y squared, comma y x cubed plus y squared along the curve C, which is going, the vertices of that triangle. And the first thing you see here, C, it's oriented negatively. We can still apply Green theorem, but if C is oriented negatively, what you do is you're gonna actually look at the line integral over the opposite direction. So I'm gonna say minus C to say it's the opposite direction. And then the good thing is that the line integral over the opposite direction along the curve, that is the exact opposite, is gonna be minus the integral along C. And then here, if it's oriented positively, then I can use Green theorem. So basically what that means is you're going to do this problem as if the curve was going in the right direction. And then at the very end, you will negate your answer. That's what that means. So here, the first thing we're gonna have to do, we're gonna use Green theorem because again, this is definitely a closed curve. And I mentioned already the orientation. So here, the region enclosed by the curve is the inside of your triangle. So that's R right there. So to find, to rewrite here, the line integral over C as a double integral, we're gonna have to first find the cross product of the vector field with the del operator. So here I'm going to take the partial with respect to x, and then here f, the partial with respect to y, and then this is the second component. So if I find the cross product, here is the determinant of that matrix. So here is going to be partial with respect to x of y x cubed plus y squared minus the partial with respect to y of x squared y squared. So here, if you take the partial with respect to x, y is treated as a constant. So it's just figure out the derivative of x cubed, which is 3x squared. So it's going to be 3y x squared. And the partial of y squared with respect to x is just 0. And then here we take the partial with respect to y of x squared y squared. So x squared is treated as a constant. So we just take the partial of y squared, which is 2y. So it's going to be 2x squared y. And by the way, here it's the same thing, just multiplication is commutative. So 3yx squared can be rewritten as 3x squared y. So here we just have x squared y. So that means that what we are left with is evaluating the double integral over that region here, that triangular region of x squared y dA. This is when we go in discussion. Should we go polar, rectangular here? As I said, I will stay rectangular because it's a triangular region. That means that our boundaries, no matter the direction you do your integration here, the order of integration, is going to be dealing with lines, which is much easier to write in rectangular coordinate than it is in polar. So I will stay in rectangular coordinates. So it's just a matter of figure out the order of integration. And here, the order dy dx is much easier because if you go dx dy, that means from left to right, you will see that there are two different left curve. If you were to brush here from the left curve, then the first part is going to be that line. But if you look in on the upper part of the triangle here, the left curve is the other line. So if you do dx dy, we're going to have to split into two regions, which means into two integrals. We don't want to do that. But if we do dy dx, sorry, if we do didn't mean that. If my region, the order will be dy dx, that means I'm brushing the region from bottom to top. And you see here, no matter where I am on the region, the bottom curve is always that line below the x-axis, and the top curve, when I brush here, is always going to be the other lines. So here it's just one region, much easier. And so here we see why the bottom curve is that line here right there. That's the bottom curve. And so here the equation of that line, obviously the y-intercept is 0. The slope, you go down 8 when you go over 4. So here the bottom curve is going to be, the slope is negative 4 over, negative 8 over 4, which is negative 2. So it's going to be negative 2x. And then the top curve, again, the y-intercept is 0, and you see that the slope, you go up 2 over 4, so it's 2 over 4, it's 1/2 x. So here that means that your region is from the bottom curve, which is 2x, to the top curve, which is 1/2 x. And then in that region, the furthermost left point is the origin, so it's x equals 0. And the farthermost right is any points on that vertical line, which is x equals 4. So those are going to be the boundary of your region. So now I'm just going to rewrite. So there's going to be an integral from 0 to 4, then from negative 2x, so that's for my y, to y equals 1/2 x squared y, and the order of integration was dy dx. So the first thing is I do the innermost integral. So it's the integral from y equals minus 2x to y equals 1/2 x of x squared y dy. So when it comes to the y variable, x squared is a constant. So it's really finding the antiderivative of y, because those guys are multiplied. The antiderivative of y is 1/2 y squared. So here we'll have x squared times 1/2 y squared, which we're going to evaluate between negative 2x and 1/2. So here, if I substitute 1/2 x for y, I get 1/2 x squared times 1/2 x that is squared minus what's going on at negative 2x. So that's going to be 1/4 x squared minus 4x squared. So that's going to be negative 15x squared, x to the 4th, sorry. So that's 1/2 x squared, parenthesis, negative 15/4 x squared. So the integral will be then minus 15 over 8x squared, oh, sorry, to the 4th. So that's the innermost integral. And so I'm going to rewrite what I found for it. And so we'll be left with evaluating the integral from 0 to 4 of negative 15/8 x to the 4th ds. Now that's a simple integration that we did so many times in Calc 2. And the antiderivative of x to the 4th is 1/5 x to the 5th. There's a 15 here, so it's going to be minus 3 over 8 x to the 5th, which you will evaluate at 4 and 0. And so you get it to be negative 384 after simplification. And that, now we have to remember here, this is if C is oriented positively, which was not the case. So as I said, what that means is your line integral here, your answer will be, you negate whatever you found. So here the answer is going to be 384. So that's the only difference. Green theorem, again, only apply for positive orientation. Yes, that's true. But if it's not positive oriented, then you just use the opposite and then at the end negate your answer. So the fact that it's not in the right direction, it's not a big deal.